In July 2024, NASA's Perseverance rover spotted a rock that shouldn't be there. It's a mudstone called Chiyava Falls, and if you look closely, you'll see tiny dark circles surrounded by white rings. NASA calls them leopard spots. To the untrained eye, it's just a rock. But to an astrobiologist, this looks suspiciously like fossilized microbial waste. This might be the biggest space news in over 50 years. On Earth, when we see these specific chemical rings, it usually means microbes were feeding on iron and leaving behind a chemical mess. But we've been fooled before. Remember the Mars worm in 1996? Or the Viking false alarm in 1976? Is this just another cruel trick of Martian chemistry? Or have we finally found the holy grail of space exploration? Today, we are going to look at the evidence that has NASA holding its breath, the geopolitical race to retrieve it, and the terrifying engineering challenge of getting that rock and ourselves back to Earth. Let's look at the crime scene. Perseverance found this rock in the Jezero crater, an ancient lakebed that was once filled with water and rivers. Inside these leopard spots, the rover detected two very specific minerals, vivianite and gragite. On Earth, these minerals appear when microbes, like Geobacter, eat iron oxides for energy. It is effectively fossilized micropoop. But science is about proving yourself wrong. Could something dead create these spots? NASA scientists spent months trying to find a non-biological explanation. Theory 1. Heat. Could volcanic activity create these chemicals? It's possible, but to form gragite without life, you need temperatures between 150 and 200 degrees Celsius. The problem? Vivianite is also there, and it destroys itself in high heat. Plus, there are no volcanic sources nearby, so it wasn't heat. Theory 2. Acid. Maybe acidic water corroded the rock? This was a strong candidate. But then, Perseverance found a green mineral right next to it called olivine. Olivine is the wicked witch of minerals. If it touches acid, it dissolves rapidly. If olivine is still there, the water wasn't acidic. By process of elimination, we are running out of non-living explanations. But NASA can't say it's aliens yet. To be 100% sure, we need to look deeper. So, how do we actually prove its life? If we can get this rock to a lab, scientists will look for two specific molecular fingerprints. The first is chirality, or handedness. In nature, amino acids come in two mirror image versions, left-handed and right-handed. In non-living matter, it's a 50-50 split. But on Earth, biology is picky. Life overwhelmingly prefers left-handed amino acids. If we open that Martian rock and find a chaotic mix, it's just dust. But if we find a strong preference for one side, that is a smoking gun for biology. The second fingerprint is carbon isotopes. Living things are lazy. They prefer to eat carbon-12 because it's lighter and easier to digest than carbon-13. As a result, living things have a much higher ratio of carbon-12 than the rocks around them. If the carbon inside those leopard spots shows that same preference, it means something was eating there. But running these tests requires equipment the size of a room. We have to bring the sample home. And this is where the science hits a wall of politics. NASA's Mars Sample Return mission is in trouble. The project is complicated, requiring a lander, a rocket to launch off Mars, and an orbiter to catch it. The price tag has exploded to an estimated $11 billion. Because of this, the project has been suspended indefinitely while NASA figures out how to pay for it. The National Academy of Sciences has named this the highest priority for 2 decades running. Yet, political gridlock is threatening to kill it. But the clock is ticking. While NASA hesitates, China has announced its own sample return mission, scheduled to launch in 2028. If their timeline holds, they could have Martian rocks and potentially the proof of alien life back on Earth by 2032. Imagine the irony. NASA's rover finds the evidence, but China's rocket brings it home. This isn't just science anymore, it's a geopolitical race. Whether it's a robot retrieving rocks or Elon Musk sending humans, getting to Mars is an engineering nightmare. It all comes down to delta V, the change in velocity. Earth travels around the sun at 30 kilometers per second. Mars travels slower at 24 kilometers per second. To catch Mars, we have to speed up. But once we get there, we are moving way too fast. We have to slam on the brakes, or we'll fly right past it into the asteroid belt. And stopping on Mars is harder than on Earth. Mars has an atmosphere, but it's incredibly thin. Terminal velocity, the fastest speed you can fall, is 5 times faster on Mars than on Earth. Parachutes barely work for heavy ships. This forces vehicles like SpaceX's Starship to perform the belly flop. The ship falls sideways to generate drag, flipping vertical only at the last second to fire engines. If those engines fire a millisecond late, you're a crater. So, how do we solve this? There are 3 competing visions. Option 1, the Buzz Aldrin Cycler. Buzz Aldrin proposed a space bus that never stops. It swings between Earth and Mars forever using gravity assists. Astronauts would take a taxi to catch the bus as it flies by. Efficient, but if you miss your ride, you drift into the void forever. Option 2, the mini Starship engineer, Robert Zubrin, argues Musk's ship is too big. A massive ship needs massive fuel to leave Mars. Musk's plan requires 6 football fields of solar panels on Mars just to make fuel for the return trip. Zubrin suggests a smaller ship that needs 1/6 of the fuel, making survival much more likely. Option 3, the Deimos hack. But there is a cheat code. We don't have to go straight to the surface. We could stop at Mars's outer moon Deimos. The delta V to reach Deimos is only about 5.3 kilometers per second from Earth orbit. If we built a base there, ships could dock, refuel in low gravity, and then make the short hop down to Mars with full tanks. It's the difference between driving across the country on 1 tank of gas versus stopping at a service station just outside the city. Whether we use a cycler, a starship, or a moon base, we have to go. Because the answer lies in that red dust. In astrobiology, there is a concept known as the 0-1 infinity rule. It suggests that life exists in the universe in one of 3 quantities: 0, 1, or infinity. We already know the answer is not 0. If the answer is 1, then we are truly alone, a single spark in the dark. But if we confirm that those spots on Mars are actually life, the number doesn't simply become 2, it becomes infinity. It would prove that life is a natural consequence of the universe, rather than a miracle. Those tiny spots in the Cheyava Falls rock are telling us that we might have had neighbors all along. We just need the will and the rockets to go and shake their hands. Do you think the Leopard spots are proof of aliens? And who gets there first? NASA, SpaceX, or China? Let me know in the comments. Thanks for watching.